Hey, this is Jay. Today we are going to talk about Surrogate model and PyLauncher. So PyLauncher works at TACC. So let's begin with Surrogate model. So why do we need Surrogate model? In many scientific and engineering problems, running high fidelity simulations or experiments can be extremely time consuming and computationally expensive. For example, simulating the behavior of a nuclear reactor or running a detailed dynamics model may take hours or like days. The surrogate models, also known as meta models or emulator, but let's forget about it, serve as fast and approximate alternatives to these complex models. They are trained using data from a small number of simulations or many, and can then be used to predict outcomes much more faster. As a nuclear engineer, I often rely on a large number of simulations to analyze complex reactor behaviors. However, rerunning a full simulation every time a small change is made to the info file can be highly inefficient. In such cases, it's more practical to uh, first run a large set of simulations and build a surrogate model that captures the system's behavior. This approach significantly reduces computational costs and enables faster decision making. Moreover, surrogate models are essential when real-time responses are required or when building reduced order models within a larger simulation framework. They provide a powerful tool for bridging the gap between accuracy and speed in computational modeling. So, to run many simulations on tech, you may need PyLauncher. So this is the website address you can go through. So what is PyLauncher and how to set it up? So for example, you need to run a program with 1,000 different input values and you want to use 100 cores for that. PyLauncher will cycle through your list of commands using cores as they become available. So, all right, let's um, do some hands-on exercise on that. So um, let's see if I go to my work directory and see here random NCMP. And there are many directories, as you see, especially this random MCMP 1, 2, 3, 4, 6. And there are 10,000 MCMP inputs. And you want to run it like simultaneously or at a maximum computational resources, then how to set it up. So I'll let you know. So first, so you need um, uh, the the bash script for submitting your job. So for example, this is my bash script. So I'm gonna use um, a nuclear energy partition. I'm going to use the resources of ASC 2346 project. And there are 10 nodes, so I'm going to use all the nodes and set a limit, a time limit, 48 hours, like 2 days. You should add this guy, module, load, PyLauncher, and this is your Python virtual environment. And so Python, my launcher.py. Actually, you don't need it. I think you can just use your Py or Python or Python 3. It depends on yours. And then you are going to make another file called mylauncher.py. So here we go. And there are just two lines. Import PyLauncher and PyLauncher, classic launcher, command lines. Now you are going to make command line file. So I already have it here. And here you are gonna type all the runs you wanna, all the execution commands you wanna run. So for example, I want to run this guy, this guy, this guy, this guy, this guy, this guy, and all the way up to 1,000, 10,000. So there are 10,000 executions by running this line. So now what I'm gonna do is um, you just type s batch and your batch script name, and that's it. It'll run your script. So this is pretty simple and but yet really powerful. So I hope this helps build surrogate models or whatever for your research. And thanks for watching.